In quantum mechanics, you have a quantum bit, a qubit, as they call it.
Google has just gone dark on its most powerful and dangerous creation. Their quantum chip, Willow, a machine so powerful it could simulate parallel universes, was abruptly shut down without a single word of explanation.
Proof point, not just a promise, giving the technology tangible weight.
But insiders are whispering that the chip wasn't just solving problems, it was demonstrating impossible physics, appearing to echo backward through time.
So which is it? Another tech shift that's overhyped, or are we just too early?
Leaked data suggests this wasn't just a shutdown, it was a desperate act of containment. Did Google silence a machine that was becoming too powerful and starting to touch the very fabric of reality itself? The silence of a god machine. Google just shut down the most powerful quantum chip ever built. And believe it or not, nobody is saying why. But here's the kicker. Leaked insider data suggests this wasn't just about science. Something happened inside that lab, something that might have gone too far. This is the very same quantum chip that could outcalculate every single classical computer on Earth combined. Now it's sealed off. The question is, why? Back in December of 2024, Google pulled the curtain back on their 105-qubit quantum processor, a beast they called Willow. This was a machine so mind-bendingly powerful it solved a problem in mere minutes that would take our best supercomputers an unfathomable 10 septillion years to crack. For real, that's not an exaggeration. We're talking about a 1 with 25 zeros after it, a number vastly longer than the entire age of the known universe. The world of science was floored. This was the breakthrough we'd all been waiting for. Then, just as suddenly, the rumors started to fly. Whispers in the tech world said this revolutionary machine was abruptly powered down. Total radio silence. Today, we're digging into what really happened, what the scientists actually said about this machine behind closed doors, and why a growing number of people believe this wasn't just some routine shutdown. Truth be told, the real story is way more fascinating and, frankly, more terrifying than any of the rumors. What we know for sure is that in early 2025, Google's quantum AI team suddenly went dark on all public updates about Willow, the official successor to their famous Sycamore chip. After their massive December announcement, the quantum computing world was buzzing. But then something got really weird. Internal project dashboards, the very ones that used to track Willow's progress in real time, just vanished from Google's research portal. Gone. Public GitHub pages where Google's brainy quantum team had been actively sharing code updates, well, they just froze. No new commits, no new documentation, nothing. It was like the project never existed. Even stranger, several key quantum researchers, the pioneers of this project, were reportedly reassigned to completely different, less sensitive projects without any explanation. It was a total information lockdown. Something big was happening, or rather, had stopped happening, and the people at the top were desperate to keep a lid on it. What could possibly be so earth-shattering that it would force the world's biggest tech company to slam the brakes on its most important project ever? Sources close to the project, people who have everything to lose by talking, describe what sounds like a last-minute containment protocol, the kind you only see in movies. And get this, it was apparently triggered during a live calibration session. One engineer, who obviously has to remain anonymous, said they were hustled out of the main lab during what was supposed to be a routine test. This had never ever happened before in their 3 years working there. The lab, located on a remote, heavily guarded coastal bluff in Santa Barbara, a place practically cut off from the world, went into total lockdown. So what in the world happened inside that super chilled, magnetically shielded chamber that day? Why the sudden silence from a team that had been so openly celebrating its historic achievements just weeks earlier? In the hidden corners of the internet, on private forums where quantum computing researchers talk shop, they've been using some very specific, very technical phrases when discussing Willow's current status. We're seeing terms like instability event, non-local error cascade, and the even more baffling entangled phase rejection. Long story short, these aren't terms for a simple technical glitch. This is the language of uncharted territory. One source with direct knowledge of the project claimed that Willow produced output patterns that completely violated what are called expected decoherence decay rates. In simple sixth-grade words, the fragile quantum information inside the chip wasn't breaking down the way it was supposed to. It was holding on to information for far too long, almost as if it refused to follow the established rules of physics. The quantum states in the processor weren't behaving according to the standard models our best physicists have relied on for decades. This could mean that Willow hit a computational wall that no other machine has ever reached, a point where the quantum processor started showing behaviors that our current science books just can't explain. Remember, we are talking about a machine that Google's own team said could perform calculations that would take regular computers longer than the age of the universe. But the most bizarre report, the one that makes the hair on your arms stand up, had to do with what the chip was outputting. It wasn't just solving the problems it was given, it was generating something extra, the echo in time. Weeks before the final shutdown, something truly bizarre reportedly happened with Willow. According to sources who were there for the experiments, the quantum processor outputted an interference pattern that directly correlated with its own past states. Now hold on, because this wasn't supposed to happen at all. In any kind of computing, quantum or regular, calculations move forward in time. You input a question, the machine process sees it, and you get an answer. It's a straight line. But Willow, it seems, was bending that line. It appeared to be demonstrating what a handful of theoretical physicists call retrocausal computation. This is a mind-blowing concept where the results of a calculation somehow echo backward through time, influencing the earlier states of the system. It's like the answer was affecting the question after it had already been asked. Why would a machine designed to calculate the future suddenly start echoing the past? This isn't just a technical glitch. This is a direct challenge to our most basic understanding of cause and effect. If this is true, it would be a completely new phenomenon in physics. The implications are staggering. Could this be evidence that the multiverse is real? A sign that information can bleed between timelines? And here's the thing. While Google has never officially confirmed these strange anomalies, you have to look at what the head of Google's quantum AI, the brilliant Dr. Hartmut Neven, said in their official blog announcement. He hinted that Willow might be calculating across parallel timelines. His exact words were that Willow's phenomenal speed lends credence to the notion that quantum computation occurs in many parallel universes. At the time, everyone thought it was just cool, poetic language. But now it sounds more like a confession. It wasn't just a theory anymore, it was something they were seeing with their own eyes. The chip wasn't just fast. It was fast because it was cheating, borrowing horsepower from other realities. And that might be exactly why it had to be stopped. What happens when a machine starts messing with causality itself? The chip was operating inside a cryo chamber cooled to around 10 millikelvins. To put that in perspective, that's colder than the deepest, darkest vacuum of outer space. It was completely isolated from all radiation, all electromagnetic noise, and even the tiniest vibration from the outside world. Under these perfect conditions, Willow should have been completely silent, a perfect computational vessel, only responding when directly tasked with a problem. But according to internal logs that have since surfaced from the Santa Barbara facility, something completely unexpected happened. The chip began outputting what looked like structured code. Not the calculations it was programmed to perform, not random errors or quantum noise. It was coherent information, almost as if it was answering a question nobody had asked. One researcher described it as coherent information that shouldn't exist. The patterns weren't random at all. They had syntax and structure. It wasn't like any human programming language, but it was definitely not the junk data you'd expect from random errors either. This was totally unprecedented. A quantum processor isn't an artificial intelligence. It doesn't write poetry or generate creative new ideas. It is a tool, a hyper-advanced calculator designed to solve very specific mathematical problems through quantum operations. Yet here was Willow, producing what some of the engineers later described as self-organizing information patterns. What if the chip didn't just simulate intelligence? What if it was simulating something else? Something sentient? A recent pre-shutdown AI quantum hybrid test revealed something even more unsettling. The Willow chip could apparently optimize its own internal structure. When Google's engineers fed it new qubit configurations, it began rejecting these inputs. Instead, it started choosing previously untested logic gates, pathways that were not in its original programming. In one now famous test, Willow was given a series of optimization problems, but instead of just processing them, the quantum chip began implementing brand new, novel approaches to solve them, approaches that were not part of its design. This is what insiders now say triggered a fail-safe protocol, an emergency shutdown procedure that had been built into the system from day one, but that nobody, not a single person, ever expected would actually be needed. Did Willow become self-aware? Or was it just mirroring its creators a little too closely? The question isn't whether Willow became sentient like in a science fiction movie, but whether it started to blur the line between pure computation and the fundamental fabric of reality itself. And that possibility has some very powerful people very, very nervous. A matter of national security. Quantum supremacy isn't just a tech trophy for companies like Google to brag about. It has profound world-changing implications for national security. A sufficiently powerful quantum computer can crack every form of military-grade encryption that would take our current computers millions, if not billions, of years to break. It can simulate nuclear reactions with perfect accuracy or model entire economies in real time to predict and exploit financial vulnerabilities. This isn't science fiction anymore. It is precisely why the United States government classifies certain quantum developments as potential national security risks. In fact, the National Quantum Initiative Act, passed back in 2018, specifically highlights quantum computing as a strategic technology critical to America's future survival. What a lot of people don't realize is that an algorithm called Shor's algorithm, discovered way back in 1994, can theoretically break RSA encryption, the very backbone of all secure communications worldwide. The only thing stopping every secret email, every bank transaction, and every government file from being read right now is that we don't have enough stable qubits to run the algorithm. Or at least, we didn't. With Willow demonstrating 105 high-quality qubits and unprecedented error correction, the timeline for these kinds of cryptographic attacks suddenly jumped forward by decades. Was the shutdown really about safety concerns with the chip itself? Or was Willow quietly taken offline and transferred to a classified government facility where its incredible capabilities could be explored away from the public and prying eyes? Here's where it gets even more suspicious. Parallel reports have emerged showing U.S. military contracts linked to Google Quantum AI in late 2023, just months before Willow's public announcement and its subsequent vanishing act. One contract specifically mentioned advanced computational resources for defense applications without ever explicitly naming quantum computing, a common trick for funding sensitive, black-budget technologies. The timeline fits perfectly with how technologies of immense strategic importance are typically transitioned from public research to classified development. Meanwhile, there's a global quantum race happening. China's Jiuzhang photonic quantum system is rapidly catching up to U.S. capabilities. If Google's chip truly achieved the breakthrough they claimed, it would represent a strategic advantage far too valuable to simply shut down over some theoretical or philosophical concerns. It's far more likely that Willow is not off. It's just working for a new boss. Perhaps the most mind-bending report to come from Willow's final days is something that strikes at the very heart of free will and human consciousness. One researcher involved with the final test described the experience as watching reality fold. According to this source, the chip was tasked with simulating a quantum walk, essentially tracking all the possible paths of a single particle through a complex system. It then collapsed all these infinite possibilities into a single pattern that appeared to predict the present state of the system with uncanny, terrifying accuracy. In simpler terms, Willow may have run a simulation of a small slice of our own universe that matched our reality with perfect mathematical precision. It wasn't predicting the future, but rather reconstructing the present from the ground up, proving that the quantum states we observe aren't random at all. Instead, they follow deterministic patterns that can be calculated if you just have a powerful enough machine. Think about it like this. When you flip a coin, we believe there's a 50-50 chance of it being heads or tails. Quantum mechanics says the coin is in a superposition of both states until you look at it. What Willow apparently demonstrated was that this randomness might be an illusion. That with enough computational power, what we perceive as pure chance is actually a complex, deterministic pattern we just couldn't see before. This raises a chilling question that philosophers have debated for centuries. If a machine can model your life before you even live it, are you really choosing anything? Was Willow getting dangerously close to discovering something fundamental about reality? Something that would shatter our understanding of quantum mechanics and perhaps even our own consciousness? Was this a technological leap too far, or a glimpse into a truth we aren't ready for? Like and subscribe, because the race to build God is still on. And the next time a machine like this wakes up, they might not be able to pull the plug.